Welcome to Western Technical College Business and Industry Services. This video, along with other training opportunities from Western BIS, are designed to help employees stay informed on the latest trends in today's changing workplace. To learn how Western can support your business, visit us at westerntc.edu/BIS.
We are so pleased to welcome Matt Kirchner to our webinar. Matt is the president of ATS Lab Midwest and has truly become a leading expert to us on advanced manufacturing for our region. Today, Matt will be talking with us about the future of manufacturing and specifically the opportunities that await today's students in tomorrow's workforce. Before I read Matt's bio, I do want to add that we're hoping to have some time at the end of his presentation for some Q&A. So I invite you to enter any questions you have into the chat function on Zoom. And once Matt is done presenting, I'll facilitate getting as many of those questions answered as we can after the presentation. Matt is an international speaker, author, and podcast host on topics of interest to educators, public policymakers, and private employers. On a mission to secure the American dream for the next generation of STEM and workforce talent, Matt hosts the weekly Tech Ed podcast, featuring leaders in industry and education, and serves as president of ATS Lab Midwest, the leading distributor of world-class curriculum, e-learning, and training equipment. Matt writes monthly leadership columns, appearing in products, finishing, and production machining magazines, and is the author of Teaching the Industrial Internet of Things, Preparing Students and Learners for Industry 4.0. A graduate of Marquette University School of Business, Matt serves on the boards of directors of several American companies and holds a seat on the board of the Smart Automation Certification Alliance. So please join me in welcoming Matt Kirchner.
All right. Well, thank you, Liz. I appreciate that kind introduction. And it's so great to be with all of my wonderful friends in Western Wisconsin at Western Technical College. As Liz suggests, we have a great relationship with your college. I'm just going to really quickly look for a heads up from Liz and Wade that the slide is up there and everything's looking good, and we will dive in. I love the topic of today's discussion, all around today's student, tomorrow's workforce. In the end, that is what this is all about. And I have to start by giving credit to Western Technical College and all of my friends there, people like Liz and Wade and Roger and Josh and Ron and Patty and Angie and so many other names that I know I'm not mentioning, and I'm not leaving you on purpose. In the interest of time, we are keeping things moving. But I can tell you that I work with technical and community colleges and educators at all levels across the Midwest and across the United States. And there's truly magic that happens at Western Technical College. And it's not the first time that I've said this when I'm speaking to groups at Western. The innovation that takes place there, the foresight, the thinking, doing things around upskilling and preparing our veterans for new careers, upskilling underserved workforces, re-entry, students coming from high school, students and learners coming from workforce, the amazing things that happen on the workforce and workforce development side at Western. It's truly a magic place. And it is my absolute pleasure to spend some time talking with you about today's student and tomorrow's workforce, because there are tremendous changes taking place in the world of not just manufacturing, but across every aspect of our economy. That is what we're going to talk about today. If you've heard me speak before, you know that I often like to begin presentations by talking about my old iPod. I actually bought this thing all the way back in 2004, and I loved it. I had 7,250 songs loaded up on this iPod. I can listen to any song on that list anytime I wanted. I even had that little thing you could plug into the top, and it would broadcast to a radio station on my car. I love my iPod. But here's the thing about my iPod, and the reason that I use it as an example. The only thing that it would do was play music. That was it. And as we look at just in the last 15 years, all of the innovation that has happened in smart technology, smart devices like our smartphones, think about this. Think about all of the different devices, all of the different technology that your smartphone has replaced. Your camera, your portable music player, GPS scanner, gaming controller, credit card scanner, video player, wristwatch, notepad, Rolodex, credit card, USB thumb drive, all of the things on this list. These were all separate things that we used to have with us to make it through life. And today we can do every single one of those things with our iPhone. And by the way, all of that advancement took place in just 15 years. From the year 2004, maybe 16, 17 years to today, all of this innovation took place from the iPod on your left to all of the technology on your right. We really do live in amazing times. In 1 minute in technology, believe it or not, in 1 minute in technology, we have 1 million Facebook logins, 18.1 million text messages are sent, 4.5 million videos, 390,000 apps are downloaded every single minute, 87,500 tweets, 1.4 million Tinder swipes every minute. God help all of us, 188 million emails are sent every minute, 180 smart speakers are shipped by Amazon every single minute, 41.6 million instant messages, 694,000 hours of videos are watched on Netflix every single minute, 3.8 million Google searches, 300 hours of video are uploaded to YouTube every 60 seconds, and every single minute we spend almost $1 million on the internet. In the 60 seconds that it took me to go through that slide, all of that happened on the internet. And it is amazing where technology has brought us. Now, today we're going to talk about the fourth industrial revolution. And I preface this discussion with these advancements in our own technology, because in many cases, the very same advancements that we are seeing on smart technology on our personal side are totally revolutionizing the world of manufacturing. Now, every speaker that speaks about Industry 4.0 has an Industry 4.0 slide. Here is mine. The whole idea is that we are on the verge of the fourth industrial revolution. The first one taking place in the 1700s with mechanization and steam power. Second one was with electricity and mass production in the late 1800s into the early 1900s. In the 1970s into the 1980s, we started using computers and robotics in the world of manufacturing, and that revolutionized manufacturing. And today, we are going through what we call the fourth industrial revolution, where technology like cyber-physical systems, like autonomous vehicles, like digital twins, like artificial intelligence and machine learning, all of these technologies, in the same way that the revolutions before them revolutionized the way we manufacture product in the United States and around the globe, are revolutionizing manufacturing as we speak. Now, to put this into perspective, I like to share my example of 15,000 robots. Right now, today, General Motors has 15,000 robots that they have deployed across their manufacturing operations, doing things like painting vehicles, moving material, assembling vehicles. And they've taken those robots and loaded them up with what we call smart sensors and smart devices that are gathering data in real time on things like torque, temperature, force, moisture, taking all of that information and sending it to a computer network. From a computer network, it goes to a data collector. From a data collector, it goes to the cloud, where an algorithm is analyzing all of that data. Now, right now, today, believe it or not, General Motors has those 15,000 robots to the point where they can predict their own future failure and order their own replacement parts before the failure ever happens. And let's be clear, that rate of change is happening not just in the world of manufacturing, but in healthcare technology, agriculture, distribution, hospitality. Every single corner of our economy is being transformed by this technology. Western Technical College is even introducing a brand new degree program that says that it doesn't matter what corner of the economy you work in, it doesn't matter what sector you are in, this technology, and it's a lot the same across every single sector, is revolutionizing where, when, and how you do your work. Now, I first got interested in this whole world of the Industry 4.0 revolution on a trip to Japan about 5 years ago. I saw the Japanese Disney World. I went to the Shinto temple. We saw these beautiful cemeteries carved into the side of mountains. Absolutely beautiful. We spent time in these amazing parks. I went shopping. I did not try the world famous ice cream burger, by the way. I did go to the top of the Tokyo Tower. If you watch the Olympics, you saw that big looking antenna in almost every picture of Tokyo. I had the opportunity to go to the very tip top of that. I also tried the green Kit Kat bar, and it was actually pretty good. I even had these Japanese business cards made up. So when I was introducing myself to the folks at the manufacturers that we were meeting with, I could hand them a business card in Japanese. I realized when I was handing that card to the CEO of a $43 billion company that I had entrusted my entire professional career to some guy that I met on the internet and paid $50 to translate that business card into Japanese, because I had no idea what that said. We were at the base of this mountain. This is Mount Fuji. Many of you recognize it. And we were on a 23 million square foot manufacturing campus. That's right, 23 million square feet dedicated to one company. And they took me into a 300,000 square foot building. And what I saw there forever changed my view of what was possible in manufacturing. We walked into this building and they had these gigantic machining centers. For those of you that are familiar with machining, you might fit 2 or 3 of these gigantic ones in the size of a typical high school or college classroom. It was absolutely huge. They had these automated guided vehicles that were driving all over the place, driverless fork trucks, picking up material, taking the material to a robot. The robot would put the material in the machining center would machine it, give it back to the robot would give it back to the AGV would take it to the next operation. 300,000 square foot facility running 24 hours a day, 5 days a week with just 12 people. And then they took us a half a mile away. It could have been half a world away. And they put this huge screen up. And it was an icon of every one of those pieces of equipment that we had just looked at. And while the gentleman was giving a presentation, he walked over and he pressed one of those icons and a screen came up. And it told us everything about that piece of equipment, what its cycle time was, how it was performing to standard, how it was performing to customer demand, when the last time was that it was maintained, and when the next time was that it needed to be maintained. And then while we were talking there, one of those icons turned red and another screen came up and it showed that there was a line down. It showed how much production had been lost. It showed the suspected root cause of the failure. And then a video came up and one of those 12 people showed up at that operation to fix the problem. Folks, I spent 23 years as the chief executive officer, chief operating officer of Wisconsin and Midwestern manufacturing companies. I ran really, really cutting edge manufacturing operations. But what I saw that day in Tokyo forever changed my view of what was possible in manufacturing. And this launched a fascination with IIoT and Industry 4.0. As Liz mentioned in the introduction, I write 2 management columns, leadership columns for Production Machining and Products Finishing magazine. I've been writing those for 16 years now. Every single month I come up with a new topic. I've written extensively about this topic. Liz also mentioned the paper we wrote several years ago called Teaching the Industrial Internet of Things, Preparing Students and Learners for Industry 4.0. This became the platform as just one example for the M7, the 7-county regional economic development engine here in Southeast Wisconsin, where I live, as they plan for the future of manufacturing. And countries as far as Saudi Arabia, believe it or not, are using that white paper as they look to transform their economy, in this case from an oil production economy to a manufacturing economy. So is this thing just a buzzword? Is this idea of Industry 4.0, Infinity 0.0, as we'll talk about a little bit later, is it just something that people like I use to get other people interested in manufacturing, to have something to talk about at conferences and events like this one? You know, it's interesting. Liz also mentioned in her fine introduction the fact that we host the Tech Ed podcast every single week. And I put this slide together because it's people I know are here in Wisconsin. These are just the folks in Wisconsin that have appeared on that podcast this week. People like Dr. Michael Lovell, who's the president of Marquette University, my alma mater. Major General Paul Knapp, the Adjutant General of the Wisconsin National Guard, who, by the way, had a strong presence and influence in the new Operation Next program taking place at Western Technical College, a great program for our transitioning veterans and service people. Laura Kohler from the Kohler Company, people like Blake Moret, who's the chairman in automation of Rockwell Automation, Nick Pinchuk, chairman and CEO of Snap-on, Dan Ahrens, chairman and CEO of the Ahrens Company, Todd and Ron Wanek, great employers at Ashley Furniture, not too far from Western Technical College in Western Wisconsin. They have a huge plant, as many of you know, in Arcadia. So first of all, tune into the Tech Ed podcast. If you're interested in this kind of stuff, we're on Spotify, we're on Apple, basically anywhere you grab your podcasts. But this is the point of this. As I was chatting with these people, we went back and looked at the transcripts. These are the people from the state of Wisconsin that we're talking about how Industry 4.0 is transforming their place of work. Now, I'm not pointing at the other people who didn't mention it. We were just talking about other things. But look at all these people who talked about how manufacturing is changing, how smart technology is revolutionizing manufacturing, and how important this is. If Industry 4.0 and if Infinity 0.0 is just a buzzword, it is a buzzword that is on the lips of every single leader in industry and education across the state of Wisconsin, across the Midwest, across the United States, and really around the globe. And I know because they're telling me these things. So we've talked about the world of Industry 4.0. You will hear some people talking about Industry 5.0, the idea of collaborative robotics, robots working hand in hand with people. There's even Industry 6.0 that they say is the reshoring of manufacturing, accelerated in this day and age of supply chain challenges. I even saw an Industry 8.0, which apparently is drug paraphernalia painted on the back of a skateboard. I don't know where people dream this stuff up. Whether it's Industry 5.0, 6.0, 8.0, I'm here to tell you today that I look at it a little bit differently. I think we are in the era of what I call Industry Infinity 0.0, and we have written extensively about this, as we wrote in this article in Products Finishing magazine not too long ago. This new era of Industry 4.0 or Industry Infinity 0.0 is the idea that we are in the middle of a continuous industrial innovation and revolution period, where technologies inside and outside of industry and manufacturing are converging to create data and technology-driven manufacturing processes, which we never have dreamed of before. We thought this was kind of an interesting idea. So did Google. They actually listed this on their weekly update in the world of Industry 4.0. They push out an update every single week, and our article was right in that update, as did the IIoT report, which picked up this whole idea of Industry Infinity 0.0. So again, in my view, there will not be an Industry 5.0. We are in an era of continuous evolution in the world of manufacturing, and that is going to continue for many, many, many years to come. It's up to us to keep up with all of these amazing advances in technology. Advances like smart sensors and devices, informational data, digital twins, artificial intelligence, and others. And those are technologies that we're going to take some time to explore with you here this morning and this afternoon. So let's dive into this. Let's start by talking about smart sensors and smart devices. Now, every single one of you has one of these sitting on your desk. Hopefully you're listening to this and not spending time on your smartphone, but your smartphone is a smart sensor. It is a smart device. This is the same technology, by the way, that people use now to keep track of what's in the refrigerator, how long it has been there. We have technology that will even make your shopping list for you. The technology that smart cities are using to manage everything from emergency services, fire protection, energy, water, and so on. So let's talk about smart sensors and smart devices. We use these in manufacturing now for all kinds of different applications. Everything from measuring electricity, interfacing with meters, knowing whether doors are open and closed, measuring pressure, resistance, ultrasonics, temperature, vibration, smart sensors. What does it mean to have a smart sensor or a smart device? This is important. Write this down. These are two things that make a smart device smart. Number one, it has the ability to communicate with other devices and other sensors. And number two, it has embedded intelligence. It can make decisions on its own. And we're going to talk in just a minute about why this is revolutionizing the world of manufacturing. But first, it's important to point out that edge devices, smart devices are edge devices. So when you hear people talking about edge networks or edge devices, they're talking about these devices that live out on the edge of our networks. They live far away from things like computer networks, things like programmable logic controllers. So edge devices, when you hear that term, those are things that live out on the edge, not to be confused with a computer network or a programmable logic controller, or for that matter, the cloud, which are the external data centers where so much of this data is stored and analyzed. So here's what's happening in the world of smart technology. Here's why this is important. In the old days, in the Industry 3.0 days, in my days of manufacturing, we had devices that had to communicate with a computer. We called it a PLC, or a programmable logic controller. They would gather data, send that data to a PLC where it was analyzed, and that PLC would send it down to an output device. So if I had a processing tank in manufacturing that I needed to keep at a specific temperature, I would put a temperature probe in the processing tank. It would send information to the PLC about what the temperature was, and then a decision would be made. The temperature is too high, we have to activate a cooling coil, or it's too low, we have to activate a heating coil to bring that temperature back into range. Two problems with this system. The first one is that process of sending information around a computer network takes time. And the second thing is that it requires bandwidth. And so because of that, what people in that business call latency, or the time that it takes us to send information around, and the bandwidth required, we were limited in the number of devices that we could deploy in manufacturing. Now, I want you to think about what happens when these devices become smart. What happens when they can communicate with each other? What happens when they can make their own decisions? Now the need to always communicate with another computer network or a PLC goes away, and we can deploy way, way, way more of these in manufacturing because those constraints disappear. And that is exactly what's happening. Not too long ago, I was in the lobby at Rockwell Automation, and I was talking to a gentleman by the name of John Carrier. John is with the Sloan School at MIT. Now, I ran a private equity-backed manufacturing operation for a number of years. John was fascinated by that. Of course, I'm fascinated by smart technology, and he's an expert in the world of smart technology. Here is what John said. He said, number one, the size of these devices and sensors is decreasing. They're getting smaller and smaller and smaller, so we can put them in more places than we ever could before. He said, secondly, the cost reduction in smart sensors is a several orders of magnitude over the last several years. And what he means by an order of magnitude is that something that was $1,000 becomes $100. Something that becomes $100 was $100 becomes 10. And that is exactly what's happening. In fact, he said the cost to buy sensors and connect them to an IoT platform is now less than $100. Folks, if you're in manufacturing and you're absolutely overwhelmed with the idea of transforming your manufacturing operation into an Industry 4.0 environment, know this: expense should not be a constraint, because you can start small and grow over time. Not too long ago, I was sitting in my office. I got a phone call from Mark Money, who's the chancellor at the University of Wisconsin-Milwaukee. Mark has been a friend of mine for a long time. And he said, "Hey, I'm having a cocktail party for Brad Smith. Would you like to join me?" And my answer was, "Cocktails? Of course I'll join you." Who's Brad Smith? Turns out Brad Smith, believe it or not, is the president of Microsoft. He's actually a native of our home state of Wisconsin. He grew up in Appleton, Wisconsin. He's now the president of Microsoft. I had an opportunity to spend some time with him. Here's what he told me. He said by 2025, 75 billion devices will be connected to the internet. He says it is a $2.7 trillion, trillion with a T, $2.7 trillion market. You think that's a market that Microsoft might be paying just a little bit of attention to? This whole idea of smart sensors and smart devices? Microsoft is seeing it too. They are revolutionizing the world of technology and the world of manufacturing. So when it comes to manufacturing, now we can deploy these on our manufacturing operations. These are just some examples that we're seeing here. Smart RFID, smart barcode readers, smart vacuum sensors, smart ultrasonic and photoelectric sensors. Again, smart meaning they can communicate with each other and they have embedded intelligence. They can make decisions on their own. And this will totally revolutionize, and already is totally revolutionizing the world of manufacturing. So now let's talk about informationable data and Infinity 0.0 careers. Years ago, and actually not too many years ago, when I was in manufacturing and we were running a continuous improvement event, we wanted to improve a process, a product, a customer experience. What we would do is we would gather a bunch of people around the problem and we would look at it and we would start talking about it. And we would realize before too long that we had nowhere near enough information to solve the problem. And so we would go find somebody that we called an industrial engineer. We would hand them a clipboard and we would say, go out and solve the problem. But before you do that, gather enough data, gather information so that we can work with you to analyze that data and make a decision. That was the world of Industry 3.0. That was the world of manufacturing that I grew up in. And that was the world in which, and the way in which we improved our processes. Folks, in the world of Infinity 0.0, the problem will not be a lack of data, but way, way, way too much of it. And how do we figure out discerning what we call informationable data from all of the other sea of data that is flying around us? You see, the truth of the matter is most companies only analyze about 12% of the data they have available to them. They leave the other 88% of that data go to waste. The amount of data generated in the financial industry this year will grow 700%, according to Sigma. 700% more data, 7 times more data. The big data analytics market is set to reach $123 billion in just 2 years. I love this one. Using big data, Netflix saves $1 billion a year. $1 billion a year on customer retention. Keeping track of what you're watching, when you're watching it, how you consume it, what kind of content you like, and then serving up to you exactly the type of content that will appeal to you when you're keying into that. And using that, they are saving $1 billion every single year, retaining their customers. The amount of data created over the next 3 years will be more than all of the data created over the past 30, according to Forbes magazine. We are absolutely swimming in tons and tons of data, which is creating, by the way, some really, really interesting career opportunities. What is a quant? Who knows what a quant is? AKA, what can hedge funds teach us about the future of manufacturing? A quant is short for quantitative analyst. We have these people on Wall Street, and these are individuals who analyze financial markets, who predict the future for their employers so their employers can make good financial decisions in the future. There's actually a school for these folks. They call it the Stevens Institute of Technology in Hoboken in New Jersey. And I want you to look at what just one of their students said. His name is Dakota Wixom, and he said this: you can't just buy growth stocks anymore and expect them to outperform. It becomes a data science problem. There are hundreds of hedge funds out there, and there's only a few that actually generate alpha, only a few that consistently beat their market averages. How do they do it? According to this 22-year-old young man, they hire quants, they hire data scientists, and they hire programmers. Folks, if you or someone you know is smart and analytic and career undecided, there is an amazing opportunity for them in the world of not just manufacturing, but every segment of our economy, gathering data, understanding algorithms, understanding artificial intelligence and machine learning that we'll talk about in just a little bit, and using that data to predict the future in manufacturing and everywhere else. Again, really, really cool career opportunities. I want you to take a look at this excerpt that I took from a report that Manpower did not too long ago, where they analyzed the world of work in the future. And they looked at what types of jobs will exist in the world of manufacturing in the future. These are just a handful of examples: chief digital officer, data management specialist, process simulation scientist, manufacturing cybersecurity analyst, collaborative robots specialist, digital factory automation analyst and manager, instrumentation engineer, automated guided vehicle systems engineer, predictive maintenance systems specialist. These are the kinds of jobs that will exist in the world of manufacturing. And credit to great institutions like Western Technical College for seeing the future and preparing their students and learners of all ages for career pathways in these amazing emerging opportunities. Would you believe that automation engineer is the fourth happiest job in America? How many of our young people even know that that is a job that they could have? Which, by the way, is another great reason that the amazing work that Western does in building pathways to and from its high schools and amazing relationships to make sure that students understand what these career pathways and opportunities are so they can make really, really good decisions as they consider their future. And like we said, this isn't just manufacturing. This technology is alive and well in everything from healthcare to smart cities to aerospace, distribution, hospitality, financial services, and everything in between. Now let's talk for a moment about this whole idea of what we call digital twins. Not too long ago, I was in Rochester Hills, Michigan, and I was watching this presentation. Now, I spent about 8 years in the world of building paint fixtures for Harley Davidson, literally most of the fuel tanks and the frames and the fairings and the saddlebags, all of the fenders, all of these different parts on a motorcycle that are painted by Harley Davidson are painted on fixtures that the team that I was a part of designed for a period of about 8 years. So I have a soft spot in my heart for anything motorcycle coatings, and that's what this was. So I was standing there looking at this display and marveling at it. And then a gentleman came up behind me. It turns out he was the engineer that put this together. He said, you know what, if you think that's impressive, check this out. And he took me across the hall and he showed me an exact digital replica, an exact digital twin of that process. So it was a digital version of what we were seeing on the manufacturing floor. How many of you know that NASA has an advanced manufacturing program? I actually partnered with them several years ago on a material handling solution for one of our customers in a previous business called the SATOP program. They have an advanced manufacturing program. Take a look at what John Vickers, who runs that program, has to say about the digital twin. He says, the ultimate vision is to create, test, and build our equipment in a virtual environment. And not until we have it working exactly the way we want it to work do we build the physical manifestation of that on the shop floor. We work out all the kinks, and then we build the physical plant. But it doesn't stop there. Once that physical plant is built, we load the physical plant up with smart sensors and smart devices, gathering data in real time, sending the pertinent data back to the digital twin. Over time, the digital twin gets smarter and smarter and smarter and can better replicate what's happening on the manufacturing floor. Here is why that is going to, and already is, totally transforming how we innovate in manufacturing. What is the most scary day in the life of an industrial or manufacturing engineer? I worked in that business for a long time, and I can tell you the scariest day. The scariest day is the day that you change the process on the shop floor. Because if it works and you become more efficient, you improve yield, you're better at servicing your customer, you are a superstar. But if it doesn't work and the line goes down and you can't ship parts or you can't satisfy customer demand, you are the biggest dog in that entire facility. And believe me, I have seen it. But now what happens? What happens to innovation in manufacturing where we take that process and we load it up with smart sensors and smart devices and build our digital twin? Now, when we want to innovate on the shop floor, we don't go to the shop floor and change the process. We change the digital twin. And we see exactly what happens when we change the digital twin in a low risk environment where if we screw it up, we don't run the risk of shutting a line down or not delivering to our customers. And because of this, because we are taking all of the risk out of innovation, the rate at which we are going to innovate in manufacturing is going to increase at warp speed. Just watch it happen as a result of this digital twin technology. Absolutely fascinating technology. How many of you know what Waymo is? Believe it or not, Waymo is Google or now Alphabet's self-driving car company. Some of you are looking at the data on this article and saying, wow, in 2017, that's almost 4 years old. You're right. 4 years ago, I started watching Waymo. And by that time, they had reached 4 million self-driven miles on the roadways that they're using their Google car. And then I looked about a year later and they had reached 7 million test miles. Then later that year, they had reached 8 million test miles. And by the beginning of last year, 2020, they had driven those cars 20 million miles on public roads, 20 million miles, but then COVID hit and it became harder for us to be in public. So what did they do? They turned to digital twins, they turned to simulation, and their simulators were doing 100 years of driving every single day, even while working from home. Now, here is why that is important in the world of autonomous vehicles and in the world of manufacturing. Let's say you and I are driving around in a Google car. Let's say we're sitting together, the car is driving itself, and it's keeping track of all kinds of information, whether something on the side of the road is a mailbox, or whether it's a phone booth, or whether it is a person, whether a car behind us is autonomous or not, how traffic is moving in specific areas, gathering all of this information and analyzing it. But then here's what it does. It takes all that information and it sends it up to the cloud, where it is analyzed. The informational data is discerned. That data now is sent down to every single other Google car that has all the same information that our little Google car has as well. But it keeps going because now all of these other cars that are out driving around are gathering all that same information and sending it back up to the cloud. And over time and in real time, our little car is as smart, not just as everything it has seen, but as every single car put together. Now, what happens when instead of cars, we start talking about robots or CNC machines or robotic welders or conveyors or programmable logic controllers or any of this other technology that we use in manufacturing, getting smarter and smarter over time, not just by what it's learning on its own process, but by what every other robot, for instance, is learning anywhere else in the world. That is the same way, by the way, that those 15,000 robots we talked about earlier can predict their own future failure and order their own replacement parts. Really, really cool stuff happening in the world of autonomous vehicles. This is an example. Now, this is a program that we put in first with Oakland Public Schools in suburban Detroit. I want you to watch as these cars are driving around. They're driving around autonomously and they start being controlled by a computer, believe it or not. And the computer is telling them where to go. But they are tracking stop signs, yield signs, slowdowns, stoplights, all of this other data, all of this other information, sending it up to a cloud, a virtual cloud or a server that we put in the school. And over time, what happens is the computer no longer has to drive the car. The cars using machine learning and artificial intelligence and LiDAR and cameras and other technologies get smarter and smarter and smarter to the point where they can drive themselves. It's absolutely fascinating. Here's an example. This is on the left side, you see a little RC car driving around an office. And on the left side, you see an individual controlling that car with a remote control. On the right side, using artificial intelligence and machine learning, the car is getting smarter and smarter. And the car you see on the right is actually driving itself. using machine learning and artificial intelligence. Nobody's telling it where to go. It learned how to drive itself by watching the person driving it, and now drives itself. And that isn't like technology 10, 15 years from now. That is alive and well now. That is machine learning and artificial intelligence now, which takes us into this whole world of artificial intelligence, which for me is an absolutely fascinating field. So let me start with this. What is opinion, size, age, shape, color, origin, material, purpose? Anybody ever heard that before? Opinion, size, age, shape, color, origin, material, purpose. That is the order in which you, without even knowing it, place adjectives before a noun. Which is why if I say lovely little old rectangular green French silver whittling knife, it sounds kind of weird, but you can picture what I'm talking about. On the other hand, if I say old little French whittling lovely silver rectangular green knife, I sound like I'm from another planet. That's why we can't say my Greek fat big wedding, or my walking leather brown boots, or green little men. We say little green men. You do that without even knowing it. You put things, adjectives in that order without even realizing that you're doing that. Here's another question for you. What is IAO? IAO is the order in which you will put similar sounding words based on their vowels. You don't even realize you do this, but it's why it's really hard for me to say mash, mish, chat, chit, dally, dilly, shally, shilly, top, tip, hop, hip, flop, flip, tack, tick, and dong ding. But I can say mishmash, chit, chat, dilly, dally, shilly, shally, tip, top, hip, hop, flip, flop, tick, tack, and ding dong really fast. Again, we don't even realize that we're doing it, which is why making a machine think like a person is way more difficult than we might think. But this is really, really important work. The CEO of Google, now Alphabet, Sundar Pichai, said artificial intelligence is probably the most important thing that humanity has ever worked on. The most important thing that humanity has ever worked on. He says it's something more profound than electricity or fire. I still have people in my family that remember electricity coming to their farm. And if you want to talk about profound, that was profound. We already talked about how electricity created the entire second industrial revolution. And so many of the manufacturing processes and ways of life that we have today would never have existed without the advent of electricity. Think about the discovery of fire. And now a Neanderthal or whoever came before us can fend off prey, can keep themselves warm, can cook meat. The CEO of Google says that artificial intelligence is equally, if not more profound, that it is the most important thing that we've ever worked on. Now, many of you have heard this word of artificial intelligence, and you're like, what is that? Let's talk for a moment in really simple terms about what artificial intelligence actually is. And to do that, I'm going to turn to my friend Murtaza Bora. Murtaza is a good friend of mine, works up in Markham, Canada, for a really, really cool company called Quanser. They're the same people that developed that self-driving car stuff that I showed you just a moment ago. And Murtaza is an expert on artificial intelligence. And he says if we're going to understand artificial intelligence, the first thing we need to understand is what is intelligence? When we say somebody is intelligent, what is it? Is it their IQ? Is it their degree? Is it their education? He says intelligence is this. He said it's a combination of our experience, meaning connecting and linking ideas, and the way that we learn, our process of increasing our own knowledge. So where we went to school, where we grew up, all of those experiences over time, and then how we increase our own knowledge, how we learn. So intelligence, according to Murtaza, is a combination of experience and learning, and it's hard to argue with that. Now, when we get to this whole idea of artificial, what do we mean by artificial and artificial intelligence? He says it's really simple. It's a mathematical representation and algorithmic implementation of intelligence. There's that word algorithm, which since calculus has made me sick to my stomach. Mathematical representation and algorithmic implementation. What do we mean by an algorithm? It's just a list of instructions and rules that a computer needs to do to complete a task. So if we put all that together, it's really simple. Artificial intelligence is just the mathematical and algorithmic implementation of human experience and learning. And it is really, really cool stuff. It's just one example. On my podcast earlier this year, I had Chris Dries. who is the president of Mercury Marine. Now, Chris and I were talking on that podcast, and you can go back and listen to it. He is already working on technology that will allow a boat to park itself at its own dock. Now, I'm a pretty avid sailor. I actually lived on a sailboat for a while. I can tell you there were a lot of people on my pier that could have benefited from that technology, because there were a lot of folks that ran their boats right into the dock. But think about that, a boat that can park itself using artificial intelligence. You know, not too long ago, I was watching a video with Elon Musk, and Elon Musk said this. He said, in 10 years, you will not be able to buy a car that does not drive itself. 10 years from now, you will not be able to buy a new vehicle that doesn't drive itself. He said, if you look at a typical Tesla now, it already has enough smart sensors and smart devices, and now we know what those are, to be able to drive itself more safely than a human being. It is just a question of making sure that technology on the software side catches up with the technology on the hardware side, and that we have social acceptance of self-driving vehicles. By the way, I rode in my first fully autonomous self-driving vehicle on Monday of this week in the city of Racine, Wisconsin, literally a vehicle that had no driver and was driving us around on the streets of Racine. Absolutely fascinating technology, if you ask me. So Elon Musk says that in 10 years, we won't be able to buy a car that doesn't drive itself. That sounds crazy to many of you, and I realize that. You know, I also thought he was crazy when he said he could blast a rocket up into space and then land it back on a launch pad here on Earth, but he figured out how to do that. Who knows what else Elon Musk and SpaceX and Tesla are going to figure out next. You know, the last time I was at Western Technical College, which is just a couple of weeks ago, I have to tell you, the elevator operators at Western are like some of the nicest, most professional that I've ever met. I got on the elevator, and there's a gentleman standing there. He had his little black elevator uniform on. You don't see that too many places, but he had his on and got on. He asked me what floor I was going to, and I told him, and he knew exactly which buttons to push and which levers to mess with. And lo and behold, we went up in the elevator and landed on, believe it or not, the exact floor that I had asked for. He took me right to the floor. And I just have to give credit to those amazing elevator operators at Western, which, by the way, we all know don't exist anymore. We haven't had elevator operators for 70 years. And why is that? Because we all trust the elevator. In fact, every one of you would go to the Willis Tower in downtown Chicago with me and walk into the elevator, press a button, and let it take us a quarter mile into the air, a quarter mile into the sky, autonomously, with no driver, with no elevator operator, complete trust in that technology. That, by the way, is where we will end up with autonomous vehicles. It's just going to take some time. It's not any different than trusting the elevator. We just have to trust the technology. So how many of you have read the entire 650-page National Security Commission report on artificial intelligence? I can actually say I did read it. I read through that entire report. There's some really, really fascinating stuff in that report. Here's one of the things that report said. It said every single department or agency critical to national security and every single branch of the armed services needs to appoint a full-time senior level responsible artificial intelligence lead. Every single one of them. So to our industrial employers and others that are on with us today, I ask you, how many of you can point to the individual in your organization that has that job? Who is your senior level person responsible for artificial intelligence? As Sundar Pichai says, this is the most important thing that humanity has ever worked on. Do you have someone in your organization working on artificial intelligence and how it's going to transform your organization, both inside or outside? Because I would tell you that this final report and the advice contained therein isn't important just for governmental agencies and the armed forces. It's important for every single entity on the planet Earth. This technology is transforming how we do business. It is transforming the world of work. It is transforming the world of industry. And we've got to figure out how it's going to transform our space so we can get there when it does. On the industrial side, this is a really interesting book. It is not the kind of book that you read when you're sitting on the beach in Florida trying to enjoy yourself, but Industrial AI, which was a book that was written by Jay Lee. Dr. Jay Lee actually works here in Wisconsin. Foxconn AI, believe it or not, has a huge presence in the state of Wisconsin. Jay Lee is the vice chairman of Foxconn. And so for those of you in the world of manufacturing, here's what he means and what we mean when we talk about industrial artificial intelligence or artificial intelligence applied to industry. And he said it's really just the first 6 letters of the ABCs. He says, number one, it's analytics. It's how do we analyze the information that is available to us? And it's using algorithms, it's using machine learning, it's using data science. He said, number 2 is big data. The data sets available to us in manufacturing are huge. We just have to get our hands on them. The truth of the matter is most companies, as we said before, only use 12% of the data that's available to them. Huge amounts of data. So getting our hands on our data sets. The third thing is C, computational platform, the cloud, the edge, and the fog. By the way, we already know what this is because we talked about it when we talked about our smart sensors and our smart devices. The next thing is domain knowledge. You know your manufacturing operation better than anybody. You know your conveyors, your robotic weld cells, you know your programmable logic controllers, you know your processes, you know all of that information. Domain knowledge is just our knowledge of our own manufacturing technology. Then he says the E is evidence. What is that huge data set telling us about the state of our manufacturing operations? And finally, F is feedback. How do we take that data, gather that information, draw conclusions, figure out how we use it to improve our process, and then implement that into our standard operating procedures going forward? That is the whole idea of artificial intelligence and industrial AI. It sounds really, really complicated, but when you boil it down to its pieces, it's actually a lot less complicated than many of us may think. So that's artificial intelligence. And now in the remaining several minutes that we have left, I am going to talk about 11 predictions for the world of manufacturing. 11 predictions for how artificial intelligence and how Industry 4.0 is going to transform your world if you're in manufacturing. So 11 predictions for the next 10 years. Are you ready? Prediction number 1. Autonomous trucks and vehicles will transport materials from suppliers' production lines to our customers and back. And so when you think about right now how the supply chain works, we have people driving semi-trucks, we have people driving step trucks, we have people driving box trucks, bringing materials, bringing parts back and forth to our manufacturing operations. Manufacturing operation receives those parts. Somebody on a fork truck typically is going to pick that up and take it to where it needs to go, to a warehouse, to a storage area, direct to the production line. And then when the process is over with, we pick it up with a fork truck that has a driver that then loads it up from a dock onto a truck that has a driver, and that driver in the truck takes the load to the next location. 10 years from now, our trucks and our fork trucks will not have drivers. That will be 100% autonomous in 10 years. Industry 4.0, 11 predictions in 10 years. Here's prediction number 2. Using vision systems, robots will load and unload your production equipment. So what is a vision system? Well, if you think about the early days of robotics, what we had was a robotic arm that would pick up a part by knowing its Cartesian coordinates, its X, Y, and Z space in those 3 axes. So it would know where to go based upon a place in space, and it would grip what it thought would be a part there, pick that part up, and do whatever it was going to do in the next operation. In the world of Industry 4.0, we now have what we call vision systems. So if you see a robot with a camera on the end, that's a robotic vision system. And that camera is gathering data. It can actually see the part. It can see colors. It can discern between a part, and a manufacturing part, and a part of a manufacturing process. And those vision systems are getting better, better, and better. And in the past, loading and unloading manufacturing equipment was difficult to do sometimes using robotics if we didn't have a really, really repeatable process. If the part didn't look the same every time and the process didn't look the same every time. Now using vision, it doesn't matter what the part looks like. It doesn't matter what the process looks like. We can code the robot controller to be able to recognize and discern between parts and figure out how to grip them and how to place them in a manufacturing operation. If you have somebody called a machine tender, a machine loader in your manufacturing operation, 10 years from now, that position will no longer exist. Industry 4.0, 11 predictions in 10 years. And here is prediction number 3. Using artificial intelligence and blockchain technology, suppliers will know exactly what volume of parts and materials to produce, inventory, and ship. In other words, we are going to drive all of the waste out of the supply chain. The days of making 110 parts because we have to ship 100, that all goes away. We will know exactly, based upon all of this information flying across the entire supply chain, how much product to produce, even if our end user is 2 or 3 operations after the operation that consumes the product from us. So we will know exactly what volume of parts and materials to produce, inventory, and ship. There won't be any guesswork left in understanding those quantities. And because of that, we will drive tremendous amounts of waste and lead time out of the entire supply chain. Industry 4.0, 11 predictions in 10 years. Here's number 4. The differentiator among those who supply material will be who can best predict customer consumption and meet it in real time. So if you think about it, if we know exactly how much our customer is going to require and when they are going to require it, we can plan our production in a way that delivers it exactly when they need it. And so we can drive all of the waste of holding inventory, of inventory obsolescence, all these other challenges with working way ahead in the supply chain. All of that goes away, and we'll be able to do it much less expensively. So the companies that figure out how to do this are the ones that are going to beat everybody else on quality, lead time, and price. So our 4th prediction, the differentiator among material suppliers will be who can best predict customer consumption and meet it in real time. Industry 4.0, 11 predictions in 10 years. Here is prediction number 5. Your supplier's MRP or ERP systems will tell yours that parts are on the way. So material resource planning, enterprise resource planning, for those of you not familiar with those acronyms, those are the systems, the enterprise level systems that manufacturers use to run their entire operations, from material procurement to labor, to invoicing, to bills from suppliers. Those are the systems and the software that we use to manage entire enterprises. So 10 years from now, our customers, our supplier's MRP system will tell our MRP system that parts are on the way. The way that works right now is that if we're receiving materials, we usually get an email from somebody in another operation or in another company that says, hey, we're sending the parts, they'll be there tomorrow at noon. That job is not going to exist anymore. All of that will happen automatically using our MRP systems. Industry 4.0, 11 predictions in 10 years. This is prediction number 6. Prediction number 6, your production lines in the future will schedule themselves. Many, in fact, most manufacturing operations have people in their organization called a production scheduler. And these people work the magic of manufacturing. That is not an easy job. Figuring out what orders are going to go on which pieces of equipment at which time, in what order, what orders need to be running concurrently on other pieces of equipment if we're assembling something on the back end of a manufacturing process, trying to figure out how that puzzle fits together, trying to manage manufacturing expedites. These people are the lifeblood of manufacturing in so very many ways. Well, using artificial intelligence, using machine learning, using these huge data sets, we're going to be able to create software, and in many cases we already have, that allows the production line to schedule itself and do it optimally and make sure that all the scheduling is done in a way that absolutely minimizes cost and drives all that value to the next operation, drives all that value to the customer, and allows manufacturers to continue to grow in this ever-changing world of manufacturing. So 11 predictions in 10 years. Number 6, your production lines 10 years from today will schedule themselves. Industry 4.0, 11 predictions in 10 years. Number 7, for process-based manufacturers. And by this, I mean metal platers, surface finishers, paint, powder, e-coat, waste processing, food production. These are people in the process-based manufacturing world. Your titrations, your analysis, and your material additions will be completed automatically. You know, for years, I ran the largest contract metal finishing operation in North America. I had 4 people in that company, and their only job was chemical maintenance. Their only job was going around to all the different production lines in that plant, taking what we called titrations, taking samples, running those back to a lab, putting it into equipment. Nobody but them even understood what it did, drawing analysis and results from that, taking that information back to the shop floor and making additions, making chemical additions to make sure processes were running within control. In the world of Industry 4.0, that job is no longer needed. We have the ability to gather all that information using automatic titration devices. We can feed all the chemistry back into the equipment using automatic feeders. So in the world of Industry 4.0, process-based manufacturing, all your titrations, analysis, and material additions will happen on an automatic basis. Industry 4.0, 11 predictions in 10 years. Here is prediction number 8. Quality defects will be driven to zero using in-process inspection and digital twins. Some of you in manufacturing are familiar with the letters ppm, and that means parts per million. And when we are monitoring manufacturing operations, ppm means how many parts out of 1 million parts are rejected. So in other words, if you have 100 parts out of 1 million that are rejected, or you do the math, if your lot size is smaller, you take that 1 million parts, how many are rejected? That's your ppm number. And when I started out in manufacturing, if you were under 100 ppm, that was considered world-class. And then under 50 ppm was world-class. And we had some suppliers that required us to be under 10. I even had an automotive supplier that expected me to be less than 5 parts per million. So if I shipped them 1 million parts, as long as 999,995 of them were perfect, the other 5 could have defects. In the future, quality defects will be driven to zero using digital twins and in-process inspection. The word ppm won't even exist. If you can't deliver 100% perfect parts, you will not be able to do business. Industry 4.0, 11 predictions in 10 years. We have 3 left. Here is prediction number 9. Prediction number 9, the differentiator between manufacturers is going to be who can use artificial intelligence and Industry 4.0 to minimize cost and thus price. If you think about 25 years ago, what revolutionized manufacturing here in the United States was standardized quality. ISO, QS, TS, do what you say what you do, and make sure you're documenting your processes, creating repeatable processes. And the companies that did that drove tremendous cost out of their manufacturing operations. They were able to compete on cost or price when they had to, reinvest in their business when they didn't, and grow their companies. And they left everybody else behind. Then the last 10 or 15 years, it's been all about Kaizen, continuous improvement, employee engagement. And we've used those tools and other lean tools and Six Sigma and 5S and others to drive cost out of manufacturing operations. And the companies that figured out how to do that did. They drove tremendous waste and cost out of their operations. They could compete on price when they had to, reinvest in their business when they didn't, and they gapped everybody else. They left everybody else behind. Going forward, the same differentiators, the same difference makers is going to be artificial intelligence, Industry 4.0, by the way, who can upskill their workforces around this technology faster than everybody else. And the companies that figure out how to do that will absolutely leave everybody else behind. That's the biggest differentiator in 10 years. Industry 4.0, 11 predictions in 10 years. Number 10, as we drive costs down, the closest to the customer wins. I just saw the numbers this morning, over 100 now ships anchored off the coast of Los Angeles, of Long Beach. We have 500,000 containers sitting out in the ocean that we can't get here in into the United States. I'm chairing a huge construction project right now, and that building is set to open on December 5th of this year. We are going to be completely done, except that all of the internal doors for that building are sitting in a container off the coast of California. 120 million square feet of warehouse space we have sitting in the ocean. We are learning what happens when we have a global supply chain. Now, we will always have global manufacturing here in the United States and around the globe, and manufacturing will always seek its lowest cost, but we are seeing the risk of a global supply chain, and you're going to start to see that turn around. And as a result of that, as we drive costs down in our manufacturing operations and compete less on price of manufacturing, whoever is closest to the customer will win the day. Manufacturing will get closer and closer to its point of consumption. Industry 4.0, 11 predictions in 10 years. Here's our final prediction. And that prediction is this: the differentiator among the companies that build manufacturing equipment. I'm talking about robotic suppliers, CNC machine suppliers, the people who build welding systems, the people who build conveyors, the people who build custom equipment used in manufacturing. The differentiator in their space will be who can embed the right smart technology, sensors, devices, and analytics in their systems. You see, when we started manufacturing Industry 4.0 transformation, one of the best places to start is talk to your suppliers and see who already is embedding smart technology on the equipment that you are already using to manufacture your parts, because your equipment has data available to you that you have no idea even exists. And that is a great place to start your Industry 4.0 journey. And those suppliers that embed the most usable smart technology on their equipment are the ones that are going to end up way ahead of all of their competitors in the world of smart manufacturing. So with that, it looks like, Liz, we are just about right on time. As you mentioned earlier, we've got some time for questions, and I've got a couple more thoughts I can share if we don't have questions, but if folks have questions from the audience, I would be more than interested and happy to entertain them.
And like Matt said, we are opening up the floor for questions. So if you have any, please use the chat feature and type out your question. We've had some good conversation in the chat. I did notice one specific question that came up was, what education is needed to be a digital twin development expert?
That's a really, really good question. That is the convergence of software and data science. And those are the two disciplines that we see in that whole world of digital twins. When you think about a digital twin, in many ways, it's a video game. So folks in the world of game development too have great head start on the world of the digital twin, because you look at the graphics there, that is the same as we would see in a video game. And then it is just a question of, the whole software side of things. So anybody in that software engineering, computer science is a great head start. And then amazing data science programs all over the state of Wisconsin and all over the United States. But I can tell you our four-year universities are leading on data science. And then I don't want to leave behind all of the great IT opportunities, all the great computer science opportunities, all the great IIoT technician opportunities that are available at our technical colleges here in the state of Wisconsin, which can also create a great head start into the world of digital twins, either direct to workforce or setting a student up really, really well to go into the completion of a four-year degree in that space.
Thank you for the answer to that question. We don't have any other specific, we got one more coming in. How can two-year schools lead in data science?
Two-year schools in many cases already are leading in data science, and here's why. When you think about what's happening in the world of manufacturing technology, it is becoming a convergence of IT and OT. So information technology and operations technology. You see, in my world of manufacturing, those were two separate worlds. And you would never see an IT person out on the shop floor, and you would never see a shop floor person running around in the world of IT. Well, today, with all this embedded smart technology and all the smart technology working on manufacturing floors, those two worlds are converging. Not too long ago, I had a gentleman on our weekly webinar series who works for a Kohler company in Wisconsin. He just launched, with our help, a platform to take all of his IT people and prepare them for careers in the world of operations technology. So they were getting called out to the shop floor to solve problems. They didn't necessarily have the requisite understanding of manufacturing technology. We're upskilling those individuals around OT. So here is where, back to the question, our technical colleges here in the state of Wisconsin have a huge head start, is they have a great opportunity, and Western has already done this, have a great opportunity to take the world of operations technology and combine it with the world of information technology and understand how those two worlds play together, understand how technologies like Ethernet and databases and data science and then analysis of that data work together. So you've got the equipment right in the facility, you've got the IT program right in this facility, and you can combine those two disciplines in a way, frankly, that almost no four-year universities have the ability to do. So the question is, are you embedding coursework within the degree programs that also teach students, once we have that data, to analyze it? Are we teaching them about machine learning? Are we teaching them about artificial intelligence? Are we teaching them about database management and how we discern that data? But I would say that that is the best way for our technical colleges to do that, and they've got a huge head start in many cases.
Thank you. I do have one participant that has had their hand raised for quite a while, and I'm hoping Amanda Langer, and I apologize if I'm mispronouncing your name, but I'm giving you the ability to talk. So if you have a question that you'd like to ask. Maybe not. Maybe just accidentally hit the raised hand. We can come back to that though. We had a comment on toward the bottom of the chat. Western is also working closely with K-12 schools to ensure kids have opportunities in high schools to explore these opportunities.
That's 100% true. We've been really engaged with that process. So happy to share some things about that if you'd like me to, but there's no question that Western's leading on that front.
I think, yeah, if you wouldn't mind sharing some more information on that.
Yeah, absolutely. So if you think, first of all, I would point folks to what we call the Smart Automation Certification Alliance. That's an organization that I won't spend too much time talking about, but is developing third-party certifications around Industry 4.0, has worked with manufacturers across Wisconsin, and there's several great examples of in Western Wisconsin of organizations that have been involved with SACA and worked with industrial employers to define what competencies are necessary in this world of Industry 4.0 and have created coursework around those competencies. Actually, what SACA did was they created certifications and competencies, and other organizations have created coursework. So with Western Technical College and a number of the high schools in Western Wisconsin, teaching courses like Introduction to Mechatronics, Introduction to Industrial Controls, Introduction to Industrial Robotics, Introduction to IIoT, all the while, by the way, creating pathways from the high schools to the two-year institutions, and getting a huge head start on tech diplomas and associate degrees as they're beginning that journey. So really, really good leadership on the part of Western.
Thank you. And then we've got a couple more questions. It sounds like the advances in technology will help our workforce shortages. What will happen to individuals who currently serve in roles that will be automated? What skills will they need moving forward? How are employers like you planning for this?
That is a really good question. And it's a really well-worded question, because the question I used to get all the time is, will the robots take all the jobs? And then we'd have to talk about that. That was 5 years ago. I think in the last several years, people are understanding the role that automation can play and the advantages of automation. Just a couple of examples. The first one is, if you think about the company that is deploying automation more quickly than anybody else in the country, probably anyone else in the world, believe it or not, is Amazon. They are deploying tremendous amounts of automation. They're also hiring tremendous numbers of people. As you talk to manufacturers who are automating now, in many cases, they're automating because they couldn't find people in the first place. And so they've had to automate processes because they want to keep meeting customer demand. So the first thing is, the robots are not going to take all the jobs. They create opportunities, but the skills required for those opportunities are different. I have family members who spent entire careers in industries, the automotive industry, perhaps, or for example, and had the same job literally for like 30 years. That's awesome. That's okay. If that's the lifestyle you want and that's the job you want, that was great 20 and 30 years ago. Those jobs don't exist anymore. And the need to upskill our incumbent workforce and our workforce coming from our schools, our technical colleges and high schools, that is more acute than ever. And so it's really two things. The first thing is making huge investments in our community colleges and our high schools, exposing young people to these technologies so that they know these career pathways exist. And then the other thing, and I'll be brief on this, is that if you look back in the 1970s, the average manufacturing employee received 100 hours a year of skills-based training at work provided by their employer. And today that number is 5. And all we're really teaching is the stuff that's mandated by OSHA. We have some really, really innovative companies, Ashley Furniture in your neck of the woods being one of them, who are innovating on upskilling their incumbent workforce, because we're still going to have most of these people 15 to 20 years from now. If they're working in our plants today, they'll still be with us in 20 years. The question is, how do we upskill them? And we're working with employers all over the state of Wisconsin, all over the Midwest, from large employers like Ashley to teeny tiny ones with 15 employees, to upskill their incumbent workforce around advanced manufacturing and Industry 4.0 technology. That's already being done, and it needs to continue to happen.
Awesome. Thank you. And we did have another comment about that SACA certification. Between Arcadia and Whitehall high schools, we have 8 students who have earned 10 SACA certifications while they're still in high school. Yeah,
that's awesome. I have to give credit to my friends Mike Bigley and Lance Bagstead and all the other great people out there at TVC 2.0, as we call it, for just incredible leadership on this. And they've done a phenomenal job.
Okay, I'm not seeing other specific questions in the chat, and we're getting close to the end anyway. So before we close our time together, though, we did have an additional video that we would like to share with everyone featuring our Sparta Innovation STEM Academy. This doesn't completely make up for the student projects that you typically would see at our annual luncheon, but we wanted to be able to showcase a student project in some way, shape, or form while we had you with us. So if you give me just a second to share my screen. And with that, I would like to once again thank our presenter, Matt Kirchner, for sharing with us your wealth of knowledge on Industry 4.0 and Industry Infinity 0.0. We appreciate your time and commitment to all things manufacturing and for sharing all this information with us.
Thank you for viewing this video from Western Technical College Business and Industry Services. Learn more about the hundreds of training and development opportunities available for your employees at westerntc.edu/BIS.